Hey, look Mum No Computer here, and today we're going to talk about a pretty mean machine that doesn't actually exist yet. Approximately 2 years ago, I put up one of my first Look Mum No Computer videos, which was a video of me playing a song on something called the Gameboy Triple Oscillator. Basically, 3 Game Boys that were controlled by the same Arduino Boy MIDI interface that were bouncing off each other, which you could detune slightly to make it sound really fat. It was a really cool and fancy machine. But it's looking pretty sorry for itself nowadays. This wasn't the first time I actually built that project. I actually made it for the first time 7 years ago when I got into Game Boys for the first time, as well as discovering Arduino Boy by Trash80. Ah, the memories. The memories. Anyway, check out this video of that one. But yeah, seems like a fine time to give this hot tamale an upgrade. So what am I talking about? Well, let's have a chat, shall we? This is a lovely Game Boy, looking all beautiful in 1991-ish, maybe 1989 if we're a little bit more specific. But we're talking about 2016. That's when 3 Game Boys actually made me happy. You know, 3 Game Boys was enough. But today, that's not the case. That's not enough. So we need 3 times E equals MC squared times 22. 48 Game Boys. That sounds more like 2018, if I aren't mistaken. And what about monophonic? Haha, that is not happening anymore. I mean, you probably can. Unison mode. I'll think about that. Duophonic. Well, who do you think I am? What do you take me for? A goddamn joke? What about paraphonic? That's when you can play lots of different notes, but you only get one set of filters. No. We're talking about full 6-voice polyphony. That's right. It's gonna be like a real synthesizer. I could be a real synthesizer. It's gonna be lovely. Okay, so how are we gonna do this? Well, there's gonna be 24 oscillators per voice. That's from 8 Game Boys per voice. 24 oscillators. It's going to be pretty mean. That means there's going to be 144 oscillators overall, plus 48 pseudo noise channels. That makes me and my Game Boys very happy. 8-bit? Yeah, more like 384-bit. That's how it works, isn't it? Right? You just times all the bits together. How? How am I going to do this? Well, I haven't got a bleeding clue. Well, let's just improvise as it goes. All I know is it's going to look sort of like this. Yeah, it's going to look lovely. Those are all little Game Boys, and it's going to be massive, but I will design it so I can get it out of my house. Don't you worry, it's not going to be like the Furby organ when it's sort of, you know, imprisoned inside whatever room it's in. What's it called? Well, I don't know yet, so if anybody's got any ideas, please let me know. We'll play a lovely hangman game. A-R-T-O-P-O-O. Arto-poo. Gotta think of a better name than that. Anyway, that's enough science. Let's go and look at the more practical side of the experiment, shall we? Whew. So this is my first test rig. What is it? Why is there a Game Boy on a panel? Well, that's what they're all going to be on. Panels, if you didn't know. Basically, the thing is there's going to be 8 Game Boys by 6 Game Boys. Each column down of the 6 Game Boys needs to be synced to be exactly the same for the voices to make sense. So all of these buttons for all of the parameter changes on the Game Boys need to be synced up. And that's what this circuit does right here. The circuit's right here if you want to use it, and you can use that if you want, and it just takes triggers in to all of the buttons, all via this ribbon cable. Lovely jubbly. The other problem that this test rig solves is the fact that I need to frequency modulate the actual Game Boy and sort out vibrato. That's when I need to actually modulate the clock speed of the Game Boy. I'm using a little chip from circuitbenders.co.uk called the LTC1799 high precision oscillator. That's basically injecting oscillators straight into the crystal, saying to go quicker or slower. Ooh. We're literally controlling the clock speed of the Game Boy. But what if we add frequency modulation from another voltage source into the clock speed? Ooh. Sounds mean, it sounds already bigger. Holy moly! Holy moly, so that's taking a Game Boy and actually frequency modulating it to sound like something that isn't a Game Boy. Woo! Starting to build up already. Oh no, I'm stuck. Oh yeah. This is test rig number 2, and what the purpose of this one was to see if I could sync all of these Game Boys, these 6 Game Boys, from the same high precision oscillator, meaning that I can control them exactly the same. Let's see if that worked, shall we? Woo. The thing is, they're exactly the same, so it's going to sound like there's only one Game Boy because they're all exactly in speed. But if you look at the Game Boy screens, you'll actually see that they're all running at exactly the same speed. It was actually a headache to work this out because I actually had to add resistors to each of the wires going into them because in a way they were smelling each other's farts, which meant that they kept on crashing, but now it's working perfectly. Lovely jubbly. So that was week 1 of the yet to be named Game Boy Mega Machine. As you can see, there's still a lot of work to be done. I've been planning this for the past couple of months and I've had some amazing help and advice from Deadpan Robot, Kitch Ben, Trash 80 and circuitbenders.co.uk, so thank you very much guys, it's been a lot of help. And I want to thank the amazing supporters on Patreon because this project is pretty big and it definitely wouldn't be possible without any of you because, yeah, I think you can understand. I'm also doing a modular live stream over there tomorrow, as well as lots of updates on this project. So if you're interested, go and check that out. And yeah, I've been on my local computer. Don't forget to subscribe and don't be scared to try it.